What's a good requirement of good concrete? It meets the strength requirement as measured by the compressive strength, as everybody aware. So that also will work in detail. We will discuss in detail about the compressive strength. Then fulfill durability requirement, as I discussed right now. That also will cover in detail later on. What are the tests and the thing to resist the environment in which structure is expected to serve. So when you are designing a structure, you should know the exposure conditions. And once you are able to achieve this exposure condition, accordingly you design your structure, considering the chloride, sulfate level, then your CO2 levels, temperature variations, humidity variations. Those has to be considered while designing the structure. Merely only M20 or M30, M40 is not sufficient for durable concrete. Maybe or structurally you may require M20 or M30. But if you go to durability required, it may turn into M40 because minimum cement content is there, water cement ratio, both are playing a parallel role. So that one has to see. Then once you make a concrete, because we have seen most of the laboratory, they give a design which able to achieve the strength definitely, but it has to mix properly. Once you mix, it has to go for the transportation. And then after transportation, we'll have to place the concrete with equipment, whatever available at the project site. And it has to compact it as efficiently as possible and will be economical also. So compaction, mixing, transportation, compaction is also very important. We cannot use any dry concrete, though we are able to achieve the strength. But what happens? We are not able to transport properly. We are not able to pump it properly. So those things also we have to consider. When you are designing in laboratory, one has to understand what will happen at site, how they are going to use the concrete at site. That they have to take care. And also it is possible you have to see how I can economize my mix. Making good concrete, good quality of raw materials. Definitely the selection of raw materials is also very important. Now next will come to the proportioning of raw materials. We have seen one mix design, they use whatever earlier project, same mix design they use, and starting with that, we are able to get good results. Nobody is changing the proportion. Now, proportion of fine to coarse or binder to coarse ratio is weekly we have to check, at least weekly, because raw material which is coming on the factory from the quarry itself is not consistent quality. So that needs to be test, and reproportioning is required, maybe not daily, but at least on weekly basis. Fine to coarse, because we not get exact quality, because till now the raw material like fine and coarse aggregate. Now fine aggregate also we get only from the quarries, that is crushed stone sand. So they are not consistent in nature. So once the fines ratio or grading has changed, shape has changed, one has to change the proportion of your raw materials. It's very, very important. Otherwise, we'll have a lot of issues in concrete. And then we start what you call starting repairing the concrete at initial stage itself. That is not a good concrete technology's role. So concrete technology has got freedom to change the proportion as the materials is changing their properties. The source is same, the properties are changing, like your particle size distribution has changed, shape of the material has changed. We'll discuss this in detail later on. Okay, how they are affecting the properties of the concrete. The next come to the efficient mixing. Earlier we know only a mixer which is we are using a what you call a drum type mixer, where you do 1 2 4 1 1 1 3 1 1 2. The RPM may be around 30 RPM or 20 RPM. That also we rarely measure what is the RPM of that particular mix and whether it is mixing properly. So there is a test given in IS code to check the efficiency of mixing or mixer. That also needs to be checked regularly. But nowadays in batching plant, we have excellent mixers, like we have pan mixer or we have twin shaft mixer or single shaft mixer. They are highly efficient mixer. Why this efficient mixing is required is basically when you are making a concrete, earlier only we are using a cement, water, fine aggregate, coarse aggregate. Now cement has replaced with cement plus supplementary cementitious material. Now supplementary cementitious material is finer than the cement, like fly ash or GGBS or some amount of microfine material you are using. Those are still finer. So once you use that, theoretically you must be read this. Mixing powder is also a technique. The technologies, different technology. So whenever you are mixing such materials, you need an efficient mixer. So that is also very, very important to have that mixer, selection of mixer or whatever available mixers are there, how to get optimized mixing time. You cannot go only with the mixing time given in the batching plant manufacturer. Concrete technology is a role that he has to work out mixing time for his mix proportions. Because those studies are very rarely done by the batching plant manufacturer because they are basically mechanical engineers. They don't have concrete. So when you are there, you must see with different mixing time how it is behaving in workability, because dispersion of admixtures is also very important. Even sequence of mixing is also very important. Those details will come when you touch upon ready mix concrete or batching plant. Then transportation without segregation. Now, what is the segregation? You must have some idea. So we'll go in detail once how segregation, how to test the segregation, how to judge the test. Those also will come in way. And easy to place. Placing is important because we have the sufficient or desired workability is very difficult to place. If some concrete you do the around 90% concrete, today we do only pumping. So pumping concrete is also different design. Same concrete which is done by the bucket, and if you cannot do by the pumping. Some concrete can be placed under bucket, but the concrete which is designed for bucket may not be go for the pumping. Because pumping is totally different role to play. Then efficient compaction. Once you get the concrete, it has to go with the compaction properly. If you're not able to compact, then there's no use in the structure. And then you have curing. All these things will detail, we'll discuss this. The causes of deterioration, as we had discussed earlier. Then cracking, spalling, and lower the strength. Now you can see some of the photographs, what is happening in the structures. You can see here, whole bottom has gone because of the, see the crack. This has real structures photograph in Mumbai. Whatever we have done some investigations, those photographs are there. This is after 20-25 years. This is happening on the structures near to the Mumbai. See poor workmanship. You can see here. Now this is porous, and then definitely entry to the pollutant, and then it will react on your reinforcement reaction and start corroding. Now this contractors has got one mindset that Once I have this concrete, I can do very good plaster, and then over that you can do the paint. But plaster cannot be protected to such concrete. With the certain time, definitely it will come out. If you compare concrete, when your concrete working at say water cement ratio 0.4 and plaster you are making it a water cement ratio of 0.6 to 0.8, then you'll imagine what is the durability of that particular plaster. In real sense, plaster is not required for concrete. If you see all our infra project, bridges everywhere, we don't apply any plaster. Only residential building we are applying the plasters. As I say, plaster is only to hide the defects. It's a cosmetic. But engineer should make very good RCC, because RCC is your like a bone in your body. It's very difficult to replace very easily, like beam column, like your bones. So one has to understand that, and then accordingly you have to work with very good concrete. This is plastic settlement cracks. You can see here. Very high workable concrete, not compacted properly. You can see the cracks. This we'll discuss in detail later on. See the compaction, lack of compaction, lack of cover also. There is no space to move the aggregate. Hardly 10 mm cover is there, and you are using 20-25 mm aggregate. Definitely it will not move to the cover zone, because you see the very close reinforcement is there. How the concrete will come? So when the designer, when you specifying the spacing of reinforcement, he has to understand what type of concrete I am going to use. Whether it's very easy to draw on the drawing board, 20 bars for 50 mm center to center, but in reality at the site, what will happen? It will go to 10 mm also, because of the various reasons. Then in 10 mm, how the 20 mm concrete will go? So one has to understand that. So RCC designer also to understand what type of concrete required for this, not only the strength, how they will make the concrete, place the concrete, vibrate the concrete and get a circle. Here, see here this, the bottom of your beam, the depth of about more than 2.2 meter. And there is no concrete at the bottom itself has reached. This is the real site photographs in Mumbai. So we'll come out that how to address those issues, that will tell you. See, same close-up of that. You see, concrete has not reached at all. See this reinforcement. Now this contractor will, what will do some plastering and keep very good in this. Now such area, how to investigate, that also we'll learn in subsequent lectures and take a appropriate action, especially in the initial stage of concrete designing. This is alkali silica reaction in dams. So concern point is basically a sulfate chloride, carbon dioxide of industrial pollutant, seepage issue, corrosion of reinforcement. Now most of the building we do the design repairing. All these contractors, without understanding real issue, they do the repairs, and that will have a lot of issues. So repetitive repairs, like corrosion has taken place. Now corrosion like a cancer. You cannot stop the corrosion, but you can delay it. There are a lot of techniques are available today, but then it will go in the cost. But in initially itself you are taken care, then definitely you still become a your structure will become a slightly initial cost, but recurring cost of repairing and service life of the structure can be increased. So this, how to go about this, we'll discuss in detail in subsequent lectures. The complexity is a problem is because concrete is made locally, materials vary place to place, heterogeneous nature of concrete, and environmental variation region to region. The person he has got some experience in Mumbai and then he working at Delhi or Indore, the exposure content is totally different. So whenever you are deputed at the site, you study those areas, what is their variations level, environmental variation, how they are affect on the structure. And accordingly, we can take a call. And all these guidelines are given in IS code for the various things. So performance concrete depends on the time, environment, and concrete properties. So concrete, we are in our subsequent lecture, we are talking only about the concrete properties. See, pumpable concrete, self-compacting concrete is available today. See this surface. Then fair finish concrete. You need not have any such job we are done for REC headquarters in Delhi. The entire RCC structure made with white cement. If anybody has got chance go to Delhi, they can see this structure. Then we have pervious concrete. That is also possible for the particular application. That also we'll discuss and how to go about the design of this. Then we have special concretes, ultra high strength concrete, high volley strength concrete, maybe within say 18 hours or 24 hours you want to strength. Even after 4 hours you have to open some junctions. That also possible today to design that concrete. Then you have mass concrete for your high-rise building, your foundations depth more than 2 meter, 3 meter. At a time you need about 1000, 2000 cubic meter concrete. How to take care of your heat, hydration, that one has to see. Then lightweight concrete, high density concrete, then pervious concrete. In specific application concrete, PQC for your all the roads like Mumbai Pune road, you see that. BMC also they use PQC grade concrete. Then dry lean concrete, ultra thin white topping. You must have seen this now recently in recently what it has more than 10 years. We have used this technology in Thane or our interior roads, and it works very well. Then roller compacted concrete for your dams or even for roads. Wear resistance concrete, cold storage flooring because it is subjected to -degree, so there also need to take a care. Fair finished concrete, as I showed some photographs. Then precast concrete. Now this technology is picking up. Maybe next 10 years it will go in regular way. Precast concrete. There the requirement is different. The early strength design required, good finish is required because we are not doing any repairing on those elements later on. In concrete for PT slab, post tension lab, most of the project in Mumbai you must have seen that we design PT slabs. And then temperature control concrete. Definitely this is one of the requirement for high-rise building where concrete temperature should not go more than 70 to 70 degree at the core. So then that also will touch upon how to go about the designing of those. Now, what are the challenges in concrete? High-rise pumping is a very big issue today. Designing, because once you have about 200-meter length vertical pipeline and anything goes wrong in concrete, the entire land has to be clean again. So before putting your TM on the pumping, you must check the rheology of concrete. Now rheometers are available. So those you can utilize and go for high-rise pumping. High-rise pumping is totally different than normal pumping. Then fourth generation admixtures are available today. Today microfine materials are available. very good microfine material. Earlier we know only microsilica or silica fume. Now various materials are available, that also we'll discuss in subsequent lectures. Then mixing techniques, how to go about this, how to control the temperature of concrete, post tension. These are all issues today, challenges. My one shattering, the 3 meter height concrete we have to pour in one go without having any segregation. Even shear walls, very big shear walls is there in the high-rise building today. So how to address those issues, we'll discuss. Then large foundation. Now slowly we are going towards performance-based specifications rather than specified only for the strength. Now grade of concrete, you can see these are the general grade. Typically foundation M40. This is high-rise I am talking about, not normal. More than 20-story building. Shear walls, slabs, high early strength PT and precast, and hollow core slabs also is available today. You must have seen in precast hollow core slabs are available. Then definitely PQC and DLC.